Okay, let's go with another example of the power of the concept of ideal final result. It comes from quite important problem in let's say refrigerator business. It relates to a part of refrigerator that is called ice maker. And the evolution of ice maker of ice generating subsystem of refrigerator is like this. So first they were like aluminum trays, and it worked simple way. You pour water, you put it in the fridge and the freezing compartment, and then it is frozen, and then you have to release it. And a little bit later they realized that to have to enjoy getting the aluminum tray out and releasing it's not a really easy job. So they came up with a kind of semi-automated system that is given in the slide from the left. There is like a twisted tray. So it is like made of typically of plastic, a kind of tray. So you pour water on it and it just fills it nicely, all the cubes. And then when it is ready, you turn it upside down and then you twist it a little bit. And all tubes are supposed to go out of it. And it worked more or less okay. People were happy, but a bit later they realized to please the customer they want more automation. So and then we somehow succeeded in producing a refrigerator with a kind of push button. So you push a button and then you get your ice. So there is somewhere inside a small factory of manufacturing of ice. But look at the picture, how complex the system became. Now it's like a Frankenstein. And I have to tell you a secret that inside of freezer there is inside of a freezing compartment of refrigerator there is a machine like this, and inside of this machine there is a small heater. And the heater is designed in order to melt up a little bit the ice, so to make it easier to get out of the tray. So what you see, for example, there is on the right, on the bottom, there's a picture of it. So there's like a U-shaped pipe. It's not actually a pipe, it's a heater. So inside there is a heater. But think about how crazy the idea is. So inside of refrigerator that is frozen, it's minus 18 Celsius, there is a heater that heats up a little bit the tray like every half an hour. And it is a typical example of Frankenstein system. When you need a heater, introduce one more heater. When you need a cooler, introduce one more fan. When you need shaker, introduce shaker. So sooner or later the system becomes a kind of Frankenstein, a kind of a combination of subsystems. Because every new designer decides, okay, we'll keep everything like it is, but we'll add something. And I would like to share with you a beautiful idea. It's actually a patent of General Electric company, and so elegant. Look at the screen. What you see? The design of ice maker is very simple. So it is like it is double side. So you can make ice. You can pour water both of sides, and they're like symmetrical. But what happens when one side is frozen? Then you turn it upside down, and water comes again. And because water is warm, well, typically at least like room temperature, maybe plus 20. So it has some power to melt up a little bit the ice cubes that is below it. And because they are melted up, they go down because of gravity. So, and the solution is so elegant. You don't need heater, because heating is here already. Where there is water, if there is water, there is a heating. And it is very elegant solution. And again, let us check up how beautiful it is, because it works only when it is necessary and where it is necessary. In contrast with heater, you can run your heater as a pleasure of yours. Even when there is no water, when there is no ice, just you can push the bottom and enjoy heating. But this system is elegant because it works only when you actually have ice and actually have water. Yeah. Frankly speaking, we experimented with this design, but we realized that maybe it's not very reliable actually, not so reliable. So still you have maybe to warm up a little bit water to have a kind of reliable phenomenon of falling down cubes. But idea is 100% TRIZ idea, I would say, and 100% based on let's say at least 100% illustrates the concept of ideal final result. So how to make system simple, ideal, making itself so the system heats up itself, and therefore cheap and very simple to manufacture.